folks, it's Fast Action back in action here. In this video, we are going to look at solving inequalities for both polynomials and rational functions. We're going to start here with a problem that we've actually already done, an inequality with a quadratic. So it's important to recognize when you've got these quadratics because they're actually going to make things a whole lot easier for you, okay? So just looking at that highest degree, seeing we have a quadratic, noticing that this one actually factors really nicely. Now, if it didn't factor, we could, of course, complete the square or possibly have to use the quadratic formula to solve it. But in general, most of these are going to factor in some pretty simple way. So we're going to go ahead and we're going to solve this right-hand side. I'm going to go ahead and factor it x minus 6 and my x plus 2 to get that into that nice factored form, because what I'm looking for are the zeros. So what I'm going to do is we're going to look at this in two perspectives, even though we've done this before, broken the two down in more detail. We're going to grab those two zeros and I'm going to put them here on my number line at my -2 and my +6. Now, because this is has the inclusive here, we're looking for it to be greater than or equal to 0, and I'll get back to that in a second. But the key thing is the inclusives. I'm going to go ahead and I'm going to put solid dots here to remind myself that at these zeros I do want to include those values. Now, what we could do is we could actually go through on this quadratic and we could test each of these intervals, and we've looked at that as an option before. We could, for example, grab a -3 and we can put it in here and figure out whether we get positive or negative. And if we did put a -3 and substitute it in here, we would find that we would get some positive value. If I put in 0 into this, I would probably not put it here. I would put it into the unfactored version, and I would see that I would get a negative value, and then I would continue on and test again, and I'd get a positive. Now, when I read this inequality, this is what I said I would get back to, we do want to make sure that we're always reading our inequalities from the side with the x's. So we're reading in this direction. So we're looking for where is this quadratic greater than or equal to, in this case, y, and what we're thinking is where does this greater than or equal to 0, okay? So we can see that we are looking for the positive values, so that would be these values right here. Now, another way that we specifically looked at the quadratics is that knowing that we can sketch in a quadratic very quickly, this would be an upward turning quadratic, and sure enough, we would get the same values. We'd get these values out here where the graph is above the x-axis. So either way, we're going to get the same solution of a -infinity up to that -2, parentheses there, bracket on the -2, and then our union, and then we're going to do another bracket for our 6 to our positive infinity, okay? So that would be that solution. Now, when we have a bigger polynomial, as you can see here in our example B, what we're going to do is we're still just going to make that number line, and here's where we're probably going to make some sketches, or probably test some intervals, but depending on your comfort level on the sketching, that's also an option. So we're going to grab each of these zeros that I have here. So I have a 0 at a -1, and I have a 0 at 2, and I have a 0 at 4, okay? Now, this particular inequality, when we're looking at this one, this particular inequality is going to be greater than, but not inclusive. So I'm going to go ahead and I'm going to put open circles on each of these zeros to make sure that I don't forget that those are supposed to be open in the end. Now, be really, really careful that you don't lose this negative in the front. Sometimes those will be right there in the front. We don't want to lose that. And we're just going to start picking some values very quickly. So if I pick, for example, a value over here, I might choose, let's say, -2. So if I take that -2 and I substitute it in here, I, of course, am always going to have that negative in the very front. If I put a -2 in here, notice that it's going to be squared, so that's going to be positive. I don't actually need to do any math. And then on the next interval, it's also going to be squared, so I'm going to automatically get another positive. Don't have to do any calculation. And then I'm going to have a -2 minus a -2 minus 2, and that, of course, is going to be negative. So looking at all these signs, this all together would give me a positive value. So I'm going to label this little interval here as positive. Now, I'm going to go ahead and I'm going to test the next interval. And unlike quadratics, these are not necessarily going to flip. So on the quadratics, we knew that these would alternate, or most of the time they alternated, especially if they alternated, I should say, if we had two zeros here. But the polynomials are not necessarily going to do that. So we do need to test each of these separate intervals and look at that behavior. So on the next interval, I'm going to, of course, grab a 0. That's going to be my easiest. Don't forget, we have the negative in the front. The next two on this problem are always going to be positive because these are squared. And when I grab that 0 in there, I'm going to get another negative. So this interval turns out to be positive again. Now, I'm going to keep going. I'm going to go ahead and grab my 3. I know I have my negative in the front. The next two are going to be positive. We've already discussed why, because those are both going to be squared each time. And now when I put a 3 into this last one, we're going to get a positive number. So now our interval is going to turn out to be negative. And then our very last interval that we're going to test, we're going to grab a 5. We've been through this before. We have a negative from the front. The next two are positive because they're squared. And then the last one is going to be, let's say, 5 minus 2, which of course is positive again. So we have this negative. So this is a great example side by side to here that the quadratics, again, when we have the two zeros, are going to have this alternating pattern, but this one is not. And if you're a little confused why this is not, it's important to recognize that these are double roots. So if we actually sketched this in, we would see that because of these double roots, it's going to have that touch and turn, so it's not actually going to pass through. You could also even go ahead and type this into Desmos and see that, in fact, these intervals do, in fact, work. So now, let's grab our final answer. So our answer was supposed to be, where is this polynomial greater than 0, but not inclusive of 0? So we're looking for our positive. So I'm looking for this interval, not including the -1, and I'm looking for this interval right here. So now I'm going to have my negative infinity to my -1 parentheses this time, union, and then my -1 to my 2, okay? Now, my last one that we're going to do here is our rational functions, and it's going to be very, very similar, but there's actually some more steps that we really need to consider here because now we're going to have asymptotes. So what I want you to notice on this particular inequality is that I've got this 1 sitting here on the other side. You cannot do anything with this problem until that 1 is moved to the other side and this inequality has a 0 on the other side. I should say you can, but it's going to be really complicated. So we're going to move that 1 to the other side, and we're going to get this all together. So I'm going to have a 3x plus 2 over an x minus 4 minus a 1. I'm going to write that over 1 right away and set this less than or equal to 0. Now I'm going to get my common denominator here, so x minus 4 and an x minus 4. I'm going to remember that I'm going to flip that to a positive and take this negative, and I'm going to distribute. So I'm going to have a 3x plus 2 minus an x plus a 4. You got to be really careful with that. All over an x minus 4 less than or equal to 0. Now I can clean that all up, and I'm going to have a 2x plus a 6 all over an x minus 4 less than or equal to 0. Now we are ready to actually make our number line. And again, because rational functions have asymptotes, it's going to complicate this for us. So when we make our number line here, we are certainly going to grab the x-intercept from the numerator, and we can see that our x-intercept here is going to be a -3. And you might even want to label that as a 0 to remind yourself. Now, since this one is supposed to be inclusive, I'm going to put a solid circle there on that 0. And okay, so these are directly related right here. Now, the other value that I want to put on here is where the vertical asymptote is. And of course, functions can never, never, never include the vertical asymptote. So when I put that on my number line here as a 4, this is always going to be an open circle no matter what the problem says. So we'll label that as a vertical asymptote. If you do not include the vertical asymptotes, it's definitely going to throw off your problem. Now, we're going to go back and just like we did before, and we're going to do our little testing. So I'm going to pick a value from over here. I'm going to let's say -4, and if I put a -4 into the numerator, I am going to get something negative, okay? If I put a -4 in the denominator, I'm also going to get something negative. Negative over negative is positive. Now, when I pick a 0 here, I get a positive value in the numerator. I get a negative value in the denominator. So positive divided by negative is going to be negative in that interval. Then my last one is going to be a 5, and I'm going to get a positive in the numerator. I'm going to get a positive in the denominator. So positive over positive is positive. Once you have all that labeled, now we can go back and say we want to find the values for this function where it is less than or equal to 0. So our final answer is the negative interval, and it's this one right here, and we're going to use our bracket on our -3, and we're going to go up to the 4 with a parentheses. Okay, so you've got to be really careful. There's not a lot of patterns that you can work on these unless you happen to be working with a quadratic.